Okay, this video will show you how to do the remaining problems on the worksheet. So here, number 10, 5 out of 13 students will ride in a car instead of a van. So it doesn't matter who rides in the van, the order, it's just 5 of them are going to ride in the van. So this is going to be a combination. The order does not matter. And again, something this drastic, I doubt will be on the, it won't be on, no, they won't be that hard, okay? But this one here, remember, for a combination, you first figure out the permutation. So I got a set of 3, or 13, and it's going to be order of 5 students. So here, for the combination, I first got to figure out the permutation. So I got 5 positions. So to figure out the permutation, it'll be 13, 12 times 12 times 11 times 10. I need 5 positions, 13, 12, 11, 10. One more, 9. 1, 2, 3, 4, 5. So that will tell me the permutation, but since the order doesn't matter, I got to divide it by how many there is in the order here. So there's 5 times 4 times 3 times 2 times 1. So find the permutation, I take the set and how many I'm pulling out of the set, and then to find the combination, I take how many in the set, and I do a countdown and multiply them, 5 times 4 times 3 times 2 times 1. Then I divide the answer at the top by the answer on the bottom. So therefore, if I take this divided by this, the answer at the bottom, let's see what I get, 10, I ended up with 1,287. So you multiply 13 times 12 times 11 times 10 times 9, and then you divide it by whatever you get down here at the bottom, 5 times 4 times 3 times 2 times 1, and I ended up, or you should end up with, 1,287. Okay, how about this one, number 12? It says selecting which 7 players will be in the batting order on an 11-person team. So it's a batting order, so the order does matter. So again, this one here is going to be a, wait a minute, will be in the batting, selecting which 7 players will be in the batting order on the 11-person team. So we're not putting them in order yet. So this one's kind of tricky. I had to mark this one marked as a tricky one because the order really doesn't matter. We're just selecting who's going to be batting that game. So in this case, it's going to be a combination. So here again, we want to figure out first the permutation. We got select 7 kids out of the set of 11. So the 11 times 10 times 9 times 8 times 7, 1, 2, 3, 4, 5, 6 times 5, 1, 2, 3, 4, 5, 6, 7. So there's my 7. And since the order doesn't matter yet, we're just pulling them out. Then we got to go the countdown, 7 times 6 times 5 times 4 times 3 times 2 times 1. Okay, so that one ended up being a little bit longer. But here, now if it was permutation, if it did matter, it's easy. Then you just do this top part, and that'll be how many permutations. But since it's a combination, we don't care about the order yet. We're just pulling the kids out that are going to be batting. Then 7, then you got to look at the number of selections, 7, and do the countdown, multiplying them, and you should end up with 330 possible combinations for that one. Okay, so that was, so if you thought this was a permutation, you should have got just multiplying this top part, should have got the answer. But if you take that answer and divide it by this, you should end up at 330. Okay. And then the last two, let's see here. There are 15 applicants for 4 jobs: computer programming, software tester, manager, and system engineer. So yeah, the order does matter. We got 4 different jobs here. Okay, so out of the 15 applicants, how many possible combinations can I get for this particular set of jobs? So here, this is a permutation, so it's pretty easy. This one, you just go 15 times 14 I got 4 positions, so I got to do the first 4. 15 times 14 times 13 times 12. And if you multiply those, you should end up with 32,760 possible combinations. Okay, so you can see if you're doing hiring, a lot of applicants, it's a lot of choices you got. And then the last one, number 14, it says a group of 45 people are going to run a race. The top 3 runners earn gold, silver, and bronze. So here the order does matter. All 3 of them don't get the same medal. So the order that they finish will matter. So this will be a permutation. Okay, so therefore, out of 45 people, how many possible combinations or how many possible permutations can there be? So here I got 3 positions, so I got to do a countdown from 45, the total number in the set, and the first 3 positions, 45, 44, and 43. So therefore, if you take those 3 numbers and multiply them, it came out to 85,140. Okay. Now, if you thought if it was if the order didn't matter, if they all just get a medal, well, then you would have to divide this by 3 times 2 times 1, and that'll tell you the different combinations. Okay. So if you did it as a combination, that's what. Whoops. There's the answer. That's what you should have ended up with. But this is a permutation. Order does matter. So you can see if it's a permutation, it's a little bit easier than doing a combination. Okay, hope this was helpful, and I'll see you next time.